Hi, I'm Wyatt Murphy. I'm a very long time faculty member in the Department of Chemistry and Biochemistry. I started here in 1986, moving up from the South, and they tell me I still have a little bit of that in my voice too. Um, the research that I do in my group is focused on harnessing light as a way to conduct reactions that are useful to society. And one of the organizing features of this is that of green chemistry. So green chemistry is how do we make reactions go that we need that and avoid producing waste. We also want to avoid using raw materials that we don't need. So industry is very interested in this. It's a guiding principle for the way that they conduct their reactions now. So we're trying to build that in from the ground up. One of the ways that we do this is we've made the transition from using traditional thermal reaction methods to using microwave. And just like in your home, we use a microwave because it speeds up our cooking, but it does the same thing in the chemical synthesis process. And it also gives us more control. It makes things a lot simpler. We're trying to incorporate that in our organic synthetic labs too. This is, a very new cutting edge kind of thing. So we have we've had a great deal of success in my lab. One of the things that has helped is that some of the compounds that we use, typically those based around the iridium metal center, normally if we were to do the reactions thermally, it would take 24 to 48 hours. Well, with a microwave, we can do it in an hour. And plus, the materials we produce are pure. We use less solvent. So it very much applies to the principles of green chemistry. And we also are interested in making these molecules in order to help the environment, like reacting CO2 and capturing it in some way that's useful. The metal complexes can conduct photoredox reactions with CO2. Another aspect we're looking at is making biodiesel from algae, which is a very efficient way to capture CO2. So couple that with some of the other chemistry that's being done by some of my collaborators, that gives us a way of scavenging any CO2 that we happen to make, so we clean that up as we go along. People that are in my research group learn how to do a wide variety of different chemical techniques: fluorescence spectroscopy, absorption spectroscopy, electrochemical techniques, separation science. So when you graduate, you have a wide variety of skills that you can take to industry, along with an awareness of green chemistry, which they find valuable. In terms of how this would help people, society in general, is that the production of carbon dioxide is a big difficulty in our society. So if we can find ways to capture it or eliminate its production, then that's certainly going to help us with mitigating climate change and also to transition away from petroleum fuels. Growing biodiesel using algae, which can grow pretty much anywhere, essentially creates a closed carbon chain, because we burn the biodiesel, we are recapturing the produced carbon dioxide to just recycle it. Whereas if what we've done in the past, when we use petroleum or coal, we're releasing stored carbon dioxide from millions of years ago, or rather stored carbon, and not capturing it again. So that creates, the problems that we're dealing with now. So, we're socially conscious in the sense that we're trying to do chemistry that will help our society and yet also teach you skills that makes you marketable both to graduate schools and to industry. So thank you very much for the time, and hope that that gives you a good flavor of what we do.